Hey, everybody. Welcome to the Tom's Hardware Podcast for today, February 4th, 2025. As always, I'm Tom's Hardware Editor-in-Chief, Avram Pilch. Les is out today, but I'm joined by a very special guest, Gordon Hollingworth, the CTO of software for Raspberry Pi, the leader behind a lot of the things that us Pi users kind of use every day, like Raspberry Pi OS, like the firmware that allows for obviously network installs with HDCT boots, like even microcontroller stuff. So, is there any software element that you're not involved in with Raspberry Pi?
Oh, God, blimey. There's some bits that Eben is kind of more central around, kind of like, 3D, for example, is a thing where I kind of just sit on the side and kind of go, yeah, I kind of nod and go, yeah, that sounds great. So, because he's the guy who knows much more about like 3D stuff than me. But I still run that kind of that interaction at least with we have actually external contractors who do that kind of bit of work. But yeah. Otherwise, it is kind of like within my team anyway, at least, or the software team, and yeah.
So, how large is the software team at Raspberry Pi?
So internally, we have about 20-ish engineers, and then we have probably about sort of 4-ish at Igalia who do our 3D support for us, and a couple of individuals here and there who do little bits of pieces. So just some people who we've kind of met along the way, and they're kind of like, in random different places, different countries, and we just occasionally kind of like get them to do a little bit of work for us and that kind of thing. So yeah, something along those lines. Yeah.
Wow. And are most of your team based out of the office in Cambridge?
Yeah, they are. Yeah.
So that's great. So you obviously have a lot of different things that you work on: the OS, the firmware, the microcontroller support, standalone software like the Raspberry Pi Imager and the Raspberry Pi Connect. How do you divide up those efforts?
Oh God, it's so hard. It's that thing where like actually we haven't done the classic kind of, we've never done the classic kind of like just keep expanding with software. We've always tried to be really, really careful to kind of just do the things that we can do. So like, if anyone can do something, we would tend not to do it. It's kind of the stuff that only we can do that we will do. So, and then try to focus all our effort in providing kind of the widest kind of implementation of something, so that it kind of it gives the most people like functionality, if you see what I mean. So we do that because we don't want to go. In the end, software it's really easy to look at software as just an expense in a company, that it's just a cost, and it's like an ongoing infinite cost, which is just going to keep going on, forever. It's really hard to see software as being an investment in your product, right? And that's one of the things that we've been really, really careful to do, we do see it as an investment, and that's why we've always, we still support Raspberry Pi 1, right? Or actually, it's the same chip that's on Raspberry Pi 0. So, in fact, we still make Raspberry Pi B pluses, right? So, occasionally people do ask us for Raspberry Pi B pluses, and we do occasionally make those. So, that's now a 10-year-old product, right? So, so we have to kind of support those products, and that's really important to us.
Right. So John asked, what are the typical backgrounds of your software engineers?
Oh, this is quite fun. Pretty much not software. Like almost none of our engineers' backgrounds are software, and the reason is going back to that thing. We tend to do the stuff that only we can do. It tends to be all the low-level stuff. It's the kernel, the firmware, it's all the drivers, the super low-level drivers, and all that. So they tend to be actually electronics engineers who have interest in software. So they tend to be a much more kind of rounded kind of electronics engineer who's kind of like don't actually want to do electronics, but like find the software much more interesting. And that's basically what I did. I did electronics at university, and then I left university and decided that actually I quite enjoyed doing software. So that's what I did. I'm pretty much just a hacker, and that's the way it works.
That makes sense. So obviously this is kind of a new field and new thing that people are doing, but do you find AI useful at all in your development process?
We don't tend to use it, not internally. I've seen some people using bits and pieces of it. I'm always very skeptical about that kind of stuff, mostly because again, it's not, I can see it being used. And in fact, I have tried it myself with some application bits, some UI type development work where I kind of like, you go to an AI and say, hey, like write me an app that does a thing. And like quite often what it can do is get you kind of like almost like finding the right example for you so that you can start with something that works.
Right.
Whereas all the stuff that we tend to do is so low level that actually it's not going to do a great deal of stuff there. Theoretically, like it might be able to create you a skeleton kernel driver, but it's not going to give you a driver that actually works for our hardware. It's not going to take in a PDF of our data sheet and then output a driver for it. Or even if it did, you then have to walk through like line by line and kind of like be sure that it was actually doing the right thing. So it kind of like loses the reason for doing it, I think. We haven't yet found a good place to use it. Skeptical, a little bit skeptical, also quite, I'm always worried about like, where is, what am I going to stick into this model and where is that data going, right? I don't really want to put any kind of secret information into or anything that's protected under some NDA somewhere into a model, because I'm always worried about what that is. And of course, you'd have to be able to trust and rely on those sorts of things to be able to do for that to be done. So, but
yeah, that makes sense. I mean, I feel the same way about it as a writer, right? People are always, oh, why don't you get us to write your articles or whatever, and you can feed it information, and then you have to go through it line by line and find out that like, oh yeah, it got these details wrong or whatever. So and by the time you've described to it what it is you wanted to do, you could have done what you wanted to do.
Absolutely. And the thing is that there's that thing where like I can see how it can really help the process, right? The creation process, because it can help kind of structure like ideas, like the form, the kind of, if you want to ask like, I was going to try actually, because I've been playing around with DeepSeek R1 on a Pi 5, and one of the things I was going to do is go, okay, write me a blog post, right, about the thing, and then use it then, not use the actual output of that, but use it as to help help design that blog post rather than to actually write it, if you see what I mean.
So one thing I wanted to talk about was how you managed to get Raspberry Pi OS to work so well across old hardware and new hardware. And it seems like, I could be wrong here, it's better at managing RAM than even in the browser, let's say, than Windows is.
Yeah, I mean, so what we've done, I mean, the point being, what we've done is never leave anyone behind, right? We've tried not to leave any hardware behind. So it's mostly the reason why it works now on all of our old products isn't because we have set out to like write a new operating system for all of these products. We just kept as we went along, and we went from Pi 1 to Pi 2, Pi 3, Pi 4, Pi 5. We've just kept that support all the way there. So, and mostly the reason why we can do that is about the firmware, right? It's the firmware that does most of the hard work of kind of taking, for example, one of the things that the firmware does is as it boots up, it goes and reads the OTP, finds out what device this is, right? So, and it goes, oh, look, it's a Pi 5. And then what it does is it goes in, it loads device tree off the disk, and then it goes and modifies it, right? So it might go and read and say, well, which Pi 5 is it? Oh, it's the Pi 5 with 8 gig. Right, okay, well, I'm going to now change device tree to match the Pi 5 with 8 gig, and it might be a slight different version, and therefore it's got a different PMU on it, in which case I'm going to change the device tree to do that. So the firmware actually has a huge amount of input in just configuring the device itself. And that's probably if you like, that's the bit that actually makes it easier for us to kind of support all of those devices. And yeah, I mean, that's kind of where that's one of our advantages, I think, is having that firmware, not relying on just some random open source thing, like a U-boot or a Grub type bootloader, which therefore you then have to have your device tree. Basically, you'd have to own, a particular build would only run on one particular device if you had that, because you can't manipulate it depending on which device it is that you've loaded. So yeah, that kind of way of actually about booting the software is quite important for Raspberry Pi.
Russell asks, how often do you find yourself writing software for hardware that doesn't exist?
Every day. Yeah, it's quite funny because like people kind of go, so what are you working on now? And you're like, Raspberry Pi 6. And you're like, are you? It's like, well, what did you think we were doing? It's like, do you think we're just sat here doing nothing? It's like, no. Like every day, like after we, the day after we release, actually that's a lie. A year after we released Pi 5, we kind of stopped working on Pi 5 and we're now working on Pi 6. But actually, it's kind of like that thing where we're slowly switching over from one to the other, because obviously we're continuously supporting. So there's right now maybe say 50% of our time we're just doing support and maintenance on all of our Pi products, and then various different amounts of work on future products. So actually quite often you have to write software for hardware that doesn't exist, but there are solutions to doing that. So for example, when we developed what we call Amethyst RP2350, we actually had the whole of that chip on an FPGA, so we could actually run all of our software on an FPGA at real-time speed, very close to full kind of full speed on a single FPGA. That allows you to actually write software, exactly as it is going to work in the real hardware. The bigger chips and stuff, like when Broadcom have done their various different bits to bring up those, and we've worked with them on that, those FPGA systems just become very, very much larger. But that's kind of the clue really. There is to try to develop your software such that you're actually testing your hardware with the software you're going to be using, not some randomly created piece of software. So this is one of the problems that we used to have back in the day. I say back in the day, I mean like, like this day. This here is like a thing that predates all of Raspberry Pi. This is the thing. This is actually a chip that existed before before Pi 1, in fact. And back at this time, we would develop, like say a driver for a particular piece of hardware. Quite often, we would develop two completely different separate drivers. One is the kind of the driver that we're going to use in the future, and then the other one is the driver that we can run on, like in a simulation, to actually check that it is correct on, as you're developing silicon. And one of the problems is quite often you never found the problems until you actually you got the chip back and you actually ran the real software. So one of the things that we try to do, and I 100% push for, is to try to develop actually real software that will actually run in a Linux like environment on an FPGA, for example, or because that is the thing that is going to find the bugs earlier and stop you from making too many chips. You don't want to go wasting money. So it's really important to do that. Yeah.
So let me ask you about Raspberry Pi Connect, because I understand that's your baby. How did that come together, and what do you feel like? And do you feel like that still needs anything?
Yeah. So I think it was January 2013 when I first joined Raspberry Pi. I said to Eben, I had this idea for a thing, right? And in fact, Russell, who asked that question just there, I actually spoke to Russell about this because I was sort of going, hey, there's this thing I want to do. And Eben said, a little bit about communication systems and things. And actually, it was just way too early. But at that time, I kind of thought, well, actually, what I kind of want is, it'd be nice if all of my own Pis would appear on kind of their own virtual network, right? So that I could have I could just create my own kind of like virtual network of Pis, and that just worked. Didn't matter where they were, etc. If they were my Pis, they were all on my own little virtual network, and that would and I was like, that would be really nice to have. And then Evan pointed out that but that's also a botnet, right? I was like, oh yeah, I hadn't thought about that. Like, if somebody hacks one of those Pis, they hack all of the Pis. It's like, well, if I get a customer who's got 1,000 Pis in a big connection, and somebody hacks one of them, they now have access to everything. So actually, we kind of that's what I wanted to do, is to have this sort of communication system for Raspberry Pi, some way that I can actually communicate between my Pis. So what we actually did about sort of probably 5 years ago, something like that, maybe even 6 years ago, is to develop kind of like a database, a backend database for Raspberry Pi. So that is what actually the underlying thing of Raspberry Pi. That's kind of what it is. It's basically communicating key value pairs across a database structure, so that devices can store information and retrieve information from that database. The problem we had was, it actually was really difficult. I tried to explain this to people. I tried to show them, hey, this is this awesome thing. Isn't it brilliant? And people just looked at me with this blank face and kind of went, I don't get it. Why? What's it for? I don't understand how to use it. And that kind of stuff. So, and what I realized, and what tended to happen is that kind of faded away. Because we just didn't have the time really to spend much. We didn't have, we just didn't really have enough engineering time to go spend too much time on it. And then, whenever it was, just before Pi 5 came out, what I realized was, there was this thing that was going away, right? When we came to Pi 5, one of the big changes between Pi 4 and Pi 5 is we 100% lost the ability to do the kind of the old firmware, all of the old closed source interfaces that we had available between Pi 1 and Pi 4, that completely went away. So because of that, a lot of software, especially screen sharing software, it would use those interfaces, and that was the way. And it would not use, for example, Wayland. And we have told lots and lots of different companies who are doing this, like, you need to switch over, start using Wayland, and nothing happened. And it literally got like a month or two before Pi 5 came out, and I said to one of my guys, I was like, but this isn't that hard. We do have WayVNC, which is the Wayland VNC client. And we had some nice interactions with the guy who wrote that, and kind of we gave him some money to to basically fix a couple of bugs in for when it was running on Raspberry Pi, on Pi 5. And I said to one of my guys, I was like, but we know that stuff, that's actually quite easy to do. It's like, I know that there's this thing, this tail scale, that whatever thing that exists in the cloud, and like, if you just connect these two things together, you've got yourself like screen sharing. I was like, well, can't we do that? Isn't it hard? Because we already have this way of communicating between devices. If we just hook these two things together, wouldn't it work? And literally, Tom, who he had only just joined us by that time. He went away and he came back in like a week and went, "Hey, look, I've got this working." And I was like, "Right, come on, we're shipping this." So then it happened. And Evan, like, at the time, Evan was like, "I don't get this. I don't really understand why anybody would want this." And I was like, no, it's worth just spending some time. We'll just see what happens, see if it works, and see if people like it. And of course, as soon as I think the eye opener for Eben was the day where I said to him, "Hey, we've got this working," and I showed it to him. I was like, "Look, you can just load it up onto your Pi," and he did. He just kind of loaded it up. And then it was that night where he'd gone home and he was sat on the floor in I think Afra's bedroom, like, and as he was sat there, like, and she was trying to go to sleep, and he was just sat there on his computer, and he was kind of like, "Oh damn, I forgot to take that thing off." And he's like, "Oh, hang on, I've got I've got Pi Connect running." So he just connected into the Pi Connect like at work, and actually sat there and was just driving his Pi. And like, he didn't have to pick it up and take it home anymore. He could just leave it at work and remote control it. And there's that thing where, like, actually suddenly it makes it so much easier to be able to use remotely. And yeah, I mean, that's what I do. I have two Pis. I've got one at home, one at work, which I use all the time for doing various different bits of development. And I just use Pi Connect to go backwards and forwards, and then I just use something like GitHub just to dump all of dump my source code from one device and into the cloud, and then download it back on the other device at any time when I need to. So yeah, no, it's really, really useful. Yeah. And I don't know if you saw today, but we did tweet the growth of users on Pi, and it is literally just it's a graph that does that. So it's great to see that people enjoy it and love using it. So yeah.
So speaking of performance, do you feel like you've squeezed all the performance that you can out of the current version of Raspberry Pi OS, or are there still improvements that you want to make? And do you feel like maybe the next version of Debian will give you maybe more improvements that you want to make?
I think in general, there is no such thing as an end to the work that you can do, right? There is always work you can do for performance and optimization reasons. You have to be really careful, because you have to do optimizations that will fit within sort of the open source upstream, the open source upstream software, right? There's that thing where, like, if you go hacking a single piece of software to make it better, make it more optimal on your platform, if that doesn't go upstream, then you're going to be stuck in one of two places: either forever updating that software, right? Forever patching that software, or like just getting stuck, never being able to move forward, right? And that's kind of like, that's the classic problem with optimization. You have to be really careful to try to make optimizations that upstream want, right? That actually you're pushing on an open door, not trying to squeeze in optimizations that people don't want upstream. So a great example of that is the liftoff stuff that we have literally today pushed up into apt. So this is something that we've been promising for 12, I think I reckon probably for sort of 12 years actually, which is the ability to use the hardware available on Raspberry Pi to do overlay, which is like actually have, say, for example, as an example, right? One of the things that you could do now on a Raspberry Pi 1 is, or a 0, if you take a 0, you can do 720p, I think 720p 30 video in VLC on a Pi 1 in a browser. Sorry, not in a browser, on the desktop, right? Now, before today, then you'd have gotten a handful of frames a second, whereas now it's now 720p 30 if you enable liftoff. The reason why what this does is we actually now use the hardware available, the kind of like, we actually have some very special hardware that, as it's outputting video onto your HDMI, right? So as the video is being read from memory, so the video or the GUI, whatever it is that you're displaying, as it's being read from your SD-RAM, it can actually compose that image as it's going out the door. So it will actually, it has the ability to read from two different images, and in the hardware, put those two things together and actually put it out to your HDMI, right? So what that means is, normally what happens is you have to employ something like the GPU or the CPU to actually do that composition, right? You have to take a background, which could be, the full display, and then you have to go and read, say, a video and overlay that on top. And so you have to do all of that work inside the CPU or GPU, and then display it on your HDMI. We actually have the ability to do that in hardware as it's going out the door, if you see what I mean. And that's a thing which we've been trying to do for a really long time. But what it required Wayland, and it required a specific Wayland compositor that actually, where the guys who are upstream developing that compositor are actually, like, they are seeing that as a good direction to move in, right? Because if you turn up with some patches that do this and they don't care, then they just won't take them. They'll just go, no, I don't want that. So you'll just have to, if you want those, you're going to have to look after those yourself forever. And that, of course, what that does is it just increases, if you like, our technical debt. It increases our costs for actually supporting our software, which means we can't support as much software in future. So that's why it's really important to find just the right bits of software where you can put some time in to improve and do optimizations, and then get, like, big gains in functionality. Our next thing to look at, we have been looking at memory usage. Also, things like out of memory killers. One of the issues is I think our out of memory killer is a bit, it's not very well, it doesn't really choose applications very well to kill. So, when you're running low on memory, say, for example, on a Pi 02, because it doesn't have very much memory, as you're running low in memory, you need to choose the right applications to go and kill. And if you don't do that correctly, you just go and kill some application which is central to the operating system, and therefore the whole operating system just crashes. So, and that tends to be what happens. So again, trying to optimize how much memory we're using anyway. So try to stop that kind of like continuous growth of memory usage, because that's really difficult to do. And then try to get our memory consumption down is going to be really, it's difficult, but that's one thing that we really need to go and focus on.
Yeah, that makes a lot of sense. Well, we've taken a lot of your time, and we really appreciate it. Was there anything else that we didn't talk about that you want folks to know about what's going on with Raspberry Pi software development?
I mean, there is so much, right? I mean, as we discussed at the beginning, it's like, we do so many different things. Our focus really for the next, our focus is always about Raspberry Pi OS and developing and improving that. And especially the optimizations and the other bits and pieces. Raspberry Pi Connect is a thing that we are now kind of developing and moving forward with. So you may have seen the organizations capability, which is, allows organizations to have accounts and then have devices in their accounts, but also have users in their accounts as well. And that's going to grow in terms of its functionality. We're hoping to provide a bit more functionality to the kind of just standard user accounts. So in other words, what I'm hoping to do at some point is to have kind of like some file sharing capability there, because that would be really useful to be able to do as well. And some obviously surprising elements. There's always some fun like nice things that we can do, which we always trying to work towards. The one other thing which people have been like really want, and it's just taken us a little bit longer than we hoped for, was Imager, is to be able to provision your Pi Connect keys actually from within Imager. So you can just you could open Imager, you can program an SD card, log in, and whilst you're doing that, log into Pi Connect, put the keys on there, and then you just take once you program that SD card, you just take it out, plug it into a device, and then plug it into the wall. You don't actually ever have to plug it into a keyboard or mouse or anything, and it just appears in Pi Connect. So that would be great to be able to do. That's really exciting.
Great. I have one more question from you for Russell. Any chance of a Pi OS for desktop update?
We're not. So our next update that we're going to be working on is going to be Trixie, right? So that's the next point that we will be moving towards. Trixie at the moment has, so Debian have just announced that Trixie is kind of like they're moving towards the kind of freeze process at the moment. So they like at least defined a time scale. So over the next kind of 6 months, we would be expecting to be working on that. And when Trixie appears, when Debian frees Trixie, then we will try to get a Raspberry Pi OS update, and that would include full kind of new, everything that's changed upstream in Trixie. We're hoping actually this year it's not going to be as bad. It's not going to be as like totally different Trixie. So hopefully, for example, hopefully Trixie might be the first one where we can actually just use apt to update from Bookworm to Trixie. That would be nice to be able to do, because that's always a bit of an issue, is trying to update across releases is actually really tricky to get correct. But as you will see from like Ubuntu have had a lot of trouble recently with exactly that. So that'll be the next thing. So it's probably going to be in a 6 month kind of time window. But there are going to be some interesting, quite nice UI changes in that as well. But that's all under my hat. Yeah.
Great. Well, thank you so much, Gordon, for sharing so much of your time with us and giving everyone an update on what's going on with Raspberry Pi OS software. We really appreciate not only you joining us, but all the work you do to make this platform so special.
Yeah. No, it's been an amazing, well, yeah, 12 years now. And we're just going to keep going. We love what we do. Everybody who works for me, all of the team, the hardware engineers, software engineers, everybody at Raspberry Pi, just kind of like, we really enjoy making this computer, right? And we enjoy everything about it. There's no it's not a chore to go to work. It's not a chore doing what we do. And yeah, we're just gonna keep going. So yeah, it's great stuff.
Fantastic. Well, thank you so much for your time. We'll be back next week, the 11th, with another special guest. Until then, happy pieing, everybody.
See ya.
Yeah.